Welcome to the Radio War podcast. I'm Aitor and I'm going to tell you the origin of radioactivity and what is natural and artificial radioactivity. Radioactivity was discovered by the French scientist Antoine Henri Becquerel in 1996, almost by chance while conducting research of the fluorescence of potassium uranium double sulfate. Natural radioactivity, it comes from two sources: radioactivity materials existing on Earth and radioactivity materials generated by the interaction of cosmic rays. I pass the turn to my colleague Paula. What is the half-life?
Half-life is the probability of a radioactive atom decaying within its half-life is 50%. It means that it is the time required for exactly half-life of the entities to decay and overage. Half-life has got some uses such as carbon dating is an effective method to estimate the life of organic material. Medical imaging X-ray. Radioactive substances don't find their application in the manufacture of deadly nuclear weapons. Medicine. You will also witness the half-life concept and its frequent use in the field of medicine. Archaeology. Archaeologists also use the half-life formula to calculate the age of artifacts and geological samples discovered around the globe. The radioactive decay curve is a graph that shows the disintegration of a radioisotope against time. All radioisotopes have the same shape of decay curve, only the time scale differs. Hector, what's nuclear fission?
Nuclear fission is a process in which the nucleus of a heavy atom splits into two smaller nuclei after being hit by a neutron. It is a division that generates a large amount of energy in the form of heat, in addition to new neutrons which can be used to continue impacting and dividing other nuclei. In addition, for each split atom, much more heat is released than a conventional chemical reaction, that is, with a very small amount of material. A gigantic amount of electricity can be generated. Along with its benefits, it brings with it some risks that cannot be ignored. Although it is true that serious accidents are very rare and are avoidable, if safety measures and periodic inspections are respected. When they occur, they can have important consequences for health and the environment. And Carmen, how much important are nuclear centers?
Inside the plant sits the reactor, a heavily protected chamber filled with false rod packet. This product is called nuclear fission and it releases a heat plus more neutrons which go on to split more atoms. It's a chain reaction but not the wild explosive kind you see in movies. Engineers keep it steady and predictable. The heat from fission warms water and the primary circuit, which is kept under such high pressure and it can boil. The superhot water flows through pipes into a steam generator. There it transfers it heat to a second loaf of water. That second loaf does boil, turning into steam not enough to blast through people at incredible speed. That same heats a turbine spinning like a massive metal windmill. The turbine is connected to a generator, and when the generator spins, it produces energy. But a chain reactor needs control. That's where control rods come in. These rods absorb neutrons, push them deeper into the reactor, and the reaction slows down. Pull them out, and it speeds up. It's like adjusting the flame to a salt. Too high and things get dangerous, too low and nothing happens. Once the steam has spun turbine, it travels to a condenser. When cold water cools it back to liquid, then it's pumped to black back to the system to start the circle again. It's a loop and repeats over and over, producing huge amounts of energy, no carbon emissions. Now Angela is going to talk about nuclear fusion.
Nuclear fusion is the reverse of nuclear fission. This means that nuclear fusion happens when two small, light nuclei join together to make one heavy nucleus. Some advantages of nuclear fusion are that it produces more energy than any other known process. The fuel used is hydrogen, and it does not generate as much radioactive waste. The problem is that to make the nuclei fuse, they must be close enough, which can only happen when the matter is in a plasma state at very high temperatures. Anyway, fusion reactions occur in stars, where two hydrogen nuclei fuse together under high temperatures and pressure to form a nucleus of a helium isotope. Fusion is difficult because atomic nuclei have the same positive charge and repel each other, so they must join very quickly before this repulsion stops the process. Lola, if nuclear fusion produces very little waste, what happens with radioactive waste from other types of nuclear energy?
Uranium in its natural state is a mixture of three isotopes. The abundance of the three isotopes differs greatly. Waste must be isolated and properly stored so that it does not pose a danger to people or the environment. To use uranium as nuclear fuel, it must first undergo enrichment. This is a series of physical and chemical processes to increase the proportion of U-235 until it reaches between 3 and 5. Radioactivity substances emit high energy radiation that is harmful to health. The enriched uranium is used to manufacture cylindrical pellets of uranium oxide, which are placed in rods. This is the fuel introduced into the nuclear reactor. Anna, what are the uses of radioactivity?
Do you know any good use of radioactivity? Most people have a negative perception of radioactivity. We normally talk about atomic bombs or nuclear accidents, but rarely about beneficial uses. Medicine is one of the fields in which the benefits of radioactivity are most visible. Some of the most useful applications of radioactivity are nuclear medicine and radiotherapy, electricity generation, dating in archaeology and paleontology, food preservation, restoration of historical and artistic heritage. Nuclear medicine is a medical specialty that uses radiation to provide diagnostic information about the functioning of a person's specific organs or to treat them. Especially, the zinc cameras allow doctors to track the path of and location of these radio traces within living organisms. Yet therapy can destroy tumors, cells, and tissues by applying high doses of radiation. And Rafa, what is electricity generation?
I'm going to talk about the use of radioactivity in food preservation because it's a very important topic. Food radiation uses ionizing radiation such as gamma rays, X rays, and electron vastness to electrolyze and disinfect products, eliminating microorganisms like salmonella. It also delays fruit tipping, prevents sprouting in tubers, and controls press without affecting the food nutritional value, flavor, or texture. The process is simple, fully automated, and does not expose workers to radiation. International organizations supervise and ensure the safety of this method. The information is from the International Atomic Energy Agency and the Spanish International Agency of Nutrition and Alimentation Security. Paola, can you tell to us about the culture and historic heritage?
Many
applications of radioactivity have been developed. One of them is less common: the study, conservation, restoration, and disinfection of artistic and historic heritage. An object is not only studied or disinfected, it needs to be restored. To do this, you need irradiation to restore the chemical bonds of the object. This method consists of introduction the object in a liquid resin and then exposing it to radiation. For example, radiation-based disinfection penetrates deeply into materials, offering significant advantage over conventional methods such as fumigation, head, liquid treatments, anoxia, and dry cleaning. Radiation treatment offers very valuable tools to fight against biodegradation of our cultural heritage artifacts made from wood and other organic materials. The International Atomic Energy Agency has been at the forefront in developing radiation technology as a viable conservation method for safeguarding cultural heritage. Nuclear techniques, including radiation treatments, are environmentally friendly, producing minimal waste and avoiding the introduction of harmful chemicals into the environment. And this is all in our Radio Board podcast. We hope the concept of radioactivity is clear to you, and we'll see you in another episode of the podcast.